Hello, good day to all of you. In this episode of our NUSD Cisco files, is there any possibility that we can connect from a very far building there, that is our MIS, and to the building over there, which is 100 meters apart? So this is exactly what we are going to answer in our today's episode, the fiber optic cable. For many years, humans saw the goodness of light. He used that not only for revealing things, but also for telecommunications. Despite of using light for telecommunications, however, it has limitations and obstacles. What if there is a fog or let's say rain in from one end to another? So telecommunications is impossible for that. Is there any possibility that we can bend and control light? Yes, there is. We can control light through the use of total internal reflection. And this was first observed in 1611 by Johannes Kepler, a German scientist. And he said that light can be controlled or can be bent by any reflective material, such as water or glass. And because of that, scientists in the 1960s or 70s got an idea to put or manipulate light with the use of glass. And this is where our fiber optic came from. And now goes the question, what is a fiber optic or fiber optic cable? A fiber optic or optical fiber, according to our Cisco files, is a flexible but extremely thin transparent strand of very pure glass, not much bigger than a human hair. Bits are encoded on the fiber as light impulses, and the fiber optic cable acts as a waveguide or light pipe to transmit light between two ends with minimal loss of signal. So, in short, a fiber optic cable is a cable that transmits light or light as a medium of communication, while the copper cable uses electricity to send signals. We're going to talk about that, those advantages of fiber optic or copper cables in the next slide. In this slide, we're going to talk about the advantages of fiber optics over the copper cables. A fiber optic has a great advantage over the copper cables with regards with bandwidth. It can reach from 10 megabits per second up to 100 gigabits per second. When it comes from distance, it was the advantage of the fiber optics because it can reach from 1 to 100,000 meters. It can reach in kilometers, in short. And it has immunity against EMI, or electromagnetic interference, and RFI, and also immunity against the electrical hazard. However, when regards with the cost, it was the copper cable as the cheapest, and also from the installation skills, and the fiber optics is the most expensive and somehow challenging to install. And at the same time, when it comes from safety precautions, it was the copper cables who was the lowest, and therefore it's somehow we can say it as safe. And installing fiber optics requires a lot of precautionary measures on health and safety because if we have, for example, an accident of having fiber optic entering into body or let's say ingested or injected, it is very difficult to remove that medically because most X-ray machines cannot detect that, only the MRI. So that those are the strengths and the weakness of fiber optic cable. We now know the advantage of fiber optics and its weakness. Let us now go to the parts of the fiber optics. So the first part we have, most important, is the core. And this is where the light signals travel. And to make the light signals reflect to a waveguide, it must have a cladding. And And to protect the cladding, it must have a tight or loose configuration called the buffer, and this is made of plastic. And to protect the coating, including the internals, from the excessive bending, there must be a Kevlar material here, and that Kevlar material is similar. It looks like a hair, but it was very strong. And this thing here not only protects from bending, it also protects the cable from pulling or excessive pulling, and at the same time to deter rodents or rats from gnawing the cable. And then finally, to protect the cable from the outside environment, we must have here the cable jacket. So these are the basic parts of the fiber optics. There are two types of fiber optic cables. The first part is the single mode, and the second part is the multi-mode. The difference between the two is the core, the diameter size of the core. The single mode has a 9 microns in diameter, and the multi-mode is 50 microns in diameter. So the single mode uh, has a smallest diameter, and therefore the behavior of the light inside is straight like this. And the result is you have a fiber optic cable which is very fast and can be used in many kilometers or long distances. This type of cable is used for backbone cabling and also to connect from one office to another, or for metropolitan area network, of wide area network, you name it. And most of the time, it is used in telephony or in cable television. For short distances, we are going to use here the multi-mode. And as you can see, it has a large diameter of core, so therefore the light bounces like this. And its application is only for local area network. Okay, so those are the two types of fiber optic. Installing fiber optic cables requires a lot of precautionary measures, especially health and safety. It is suggested that when you are terminating fiber optics, it must at least have a dark table or dark ground floor so that you can collect the pieces of the remaining strands of this fiber. Because as we said before, it is very dangerous in case there is a accident. And also, installing a fiber optics requires a lot of equipment. There is a special scissor and a special scouring tool, and also a splicer and a tester. And that those things are very expensive, and the splicer alone will cost you around 279,000 pesos. And we don't have much time for this, but I put you a link here, a video, on how to install or terminate and also test the fiber optic cable. Instead of terminating fiber optics, why not purchase a ready-made one? So you can purchase a fiber patch cords instead. The only problem with this thing is that you cannot customize the distance, unlike those that we can install or we can terminate by our own. Well, there are many connectors of the fiber optics, and the most common here is the OptiJack used for short distance communication or multi-mode application. But when you are going to talk about the long distance, or let's say data center communication, which requires high-speed telecommunication, then you need E2000, SC, ST, SMA, MU, and then LC and FC. And one of the most rarest here is the ST, which is used for military applications, this one here, and E2000 can be seen on the medical equipment. With regards with connecting devices of fiber optics, one of the most common is called the media converters. If you have an existing network which is made of copper and you wish to connect it with the fiber optics, then you need this equipment, media converter. So you have here the connections for the fiber optics, and the other one is for the copper. And you can see here, this is a switch that has a lot of copper cables. And in order to convert that into fiber optics, here's the media converter. And there goes the fiber optics, which also requires another media converter to convert again back to copper cable. Here is another way to convert media from copper to fiber optics. And this is with the use of transceiver or the SFP modules. These SFP modules can be installed on Cisco switches, but of course, we have to make sure that it has an available slot to install that. And by the way, you can connect switches from another switch with this type of configuration and also with in a router. So let's have an example scenario here. We're going to have a backbone connection to the NUST campus. This is our example. We have here the central office, the MIS office, where the router is located. And we're going to connect the criminology, the College of Criminology and CICT on that building. And this is what the logical layout looks like. Here's the MIS, the College of Criminology, and the CICT. And the MIS has the router, and this too is also going to connect on that router. And to do that in the MIS, in the switch of the MIS, you're going to put a module, which is the PT switch NM. So all you have to do is to drag it there. But before dragging it, make sure you have to turn it off. So once you drag it, then this is the time you turn on again the switch. The same thing we are going to do with the College of Criminology. Going to just select this module here for the fiber optic and drag it to the equipment. Again, make sure it's off. Then when it's installed, then you turn on. Also with the CICT here. And then once you have done those modules to the switches, then it's time for you to install it to the router. Since we have three connections here, so therefore you can put three modules of this fiber optic for this router. Again, you have to turn off the router, and then once this one is installed, then you turn it on again. And once you've done the installation of the modules, then this is the time you're going to drag the fiber optic cable. And when you drag that, so you have to make sure that the gigabit 40, which is that cable, you have to enter the IP address and you have to turn it on. The same thing with the other buildings like this College of Criminology. Drag the cable, you locate the name of that gigabit, in this case, gigabit 50, then put the IP address, turn on. Also with the CICT. So you put the cable, put the IP address, and then turn on. And don't forget in the router to put the RIP settings. You put those default gateways here. You have to list, and then you have to add. And then once you add it, then it's time to you to run. And as you can see, it runs smoothly and efficiently as a screenshot on this in this scenario. Okay, so this ends our presentation, and I hope you understand the fiber optic cable. Okay, so that's it, and I wish you all the best throughout the day, and God bless you. Bye bye.